What's up, math scholars and math haters? This is Mr. W. This will be the third of 4 videos in a series on the normal distribution. Today we have to cover an idea called the z-score. Now, very basically, the z-score tells us how far away a data point on a normal distribution is from the mean, but everything that we measure has to have a unit, like inches or feet or cups or something like that. In this case, the unit for a z-score is how many standard deviations away that data point, known as x, is from the mean, which is mu, and then standard deviation is still the Greek letter sigma here. So here is the normal distribution with the regular standard deviations and the equivalent IQ scores. And I have the formula here, and we're supposed to try to find the z-score for a person with these different IQs. Now, each IQ score actually corresponds to someone famous, or maybe not quite so famous. But if we start, the first IQ score we have to find is Forrest Gump's IQ of 75. Now, if we look on this number line, we're expecting this to be somewhere between -1 and -2 standard deviations, because 75 is, of course, between 70 and 85. So if we go ahead and try to use this formula, that is going to look like that. That'll be my basic outline, so I need to start with my x, my data point, which is 75. I need to subtract from it my mean, which, if you remember up here, was 100. And I need to divide it by my standard deviation, which was 15. So now if I do this on my calculator, I need to start by finding 75 minus 100, and I'm going to do this in its order of operations steps just to show you this. This means that 75 is 25 less than 100. Now, that may seem arbitrary and actually stupid for me to say, but the fact is that that does mean that this will have a negative z-score because our standard deviation here is always positive. So let's go ahead and do that divided by positive 15. That is negative 1.6 repeating. All right. Down here we have 125. That is estimated to be Will Ferrell's IQ. So we start with our outline. Our data point was 125. We take away 100, divide that by 15. So now I'm going to actually type the whole thing in. 125 minus 100. I'm going to put parentheses around this so that my calculator does exactly what I want it to. Divide that by 15. This actually gives me positive 1.6 repeating, which I think we can see that 125 minus 100 is just 25, positive 25. So it would make sense that a negative score and a positive score would give us the same absolute value for a z-score. So I'll go ahead and put that down as positive 1.6 repeating. Over here, we have two more very famous people, Sheldon Cooper from The Big Bang Theory, whose IQ is 168, and then Mr. W himself, whose IQ is 117. So for Sheldon Cooper, I'm going to start with the exact same idea. I'm going to take 168, subtract from it 100, divide that by 15. And if I type this in my calculator, 168 minus 100, close parentheses, divided by 15. So Sheldon Cooper's IQ is about 4.5 standard deviations above the mean, 4.53 repeating. And finally, for the world-famous Mr. W, the math teacher, my IQ is 117. So 117 will be my data point. I subtract from that 100 and divide by 15. Now, you might be able to guess, if you have drawn the normal distribution for the IQ scores, that it's going to be right about 1. I'll actually go ahead and show us. 117 is probably going to be really close, or it is really close to 115, so the z-score would probably be really close to 1. So let's go ahead and actually find that out. 117 minus 100 divided by 15 gives me 1.13 repeating. As we expected, it's close to 1 standard deviation. So those are the 4 examples I wanted to give from the IQ scores distribution. I did also want to go back to pizza deliveries. And we're going to find the z-score for a few different delivery times. So to start with, here's 29 minutes. And I'll go ahead and make my problem frame. Our data point was 29 minutes. Our mean was 25, and our standard deviation was 8. So I'm going to fill those in the appropriate places. I'll go ahead and type this in my calculator. 29 minus 25 divided by 8 is 0.5. That is half a standard deviation above the mean. So that gives me a z-score of 0.5. If I come down here to 45 minutes, I would need to write in 45 minus our mean is still 25. Our standard deviation is still 8. Notice how once you're given these two numbers, they have the same spots in the actual calculation that you're doing every single time. They don't change. 45 minus 25, all divided by 8. That is 2.5 standard deviations above the mean. So that's 2.5, positive 2.5. Over here we have a delivery time of 15 minutes. So that is going to be 15 minus 25 divided by 8. Our mean and standard deviation haven't changed. All that's changed is the actual number that we're testing. So 15 minus 25, all divided by 8, gets me negative 1.25 standard deviations, which does make sense. It's between 9 and 17. It's between -2 and -1 standard deviations. And finally, for 20 minutes, I do the exact same thing, exact same process. 20 minus 25, all divided by 8. And once again, I think we can see that this is going to be negative, but somewhere between 0 and -1 standard deviations. So that's 20 minus 25, all divided by 8. I type that into my calculator, and it gives me negative 0.625, or negative 625 thousandths. So that is how we find z-scores, how we find exactly how far away a particular data point is from the mean in terms of the actual width of one of these bars that represents one standard deviation. And as always, if you're my student, good luck on your assignment. If not, I hope that this was helpful.